The idea of living forever has fascinated humanity for centuries. While true immortality remains out of reach, science is making astonishing strides toward extending human lifespan. Here are groundbreaking technologies that could revolutionize longevity. Starting off with CRISPR and gene editing. CRISPR technology was first discovered in the 1980s when scientists observed repeating sequences in bacterial DNA, later identified as part of a bacterial immune system. In 2012, Jennifer Doudna and Emmanuel Charpentier developed CRISPR-Cas9 as a precise genome editing tool. CRISPR allows scientists to edit genes with precision, potentially eliminating genetic diseases and slowing aging. Researchers are exploring ways to alter genes associated with longevity, such as the FOXO3 gene, which has been linked to longer lifespans. In addition, CRISPR is being studied for its ability to repair DNA damage, a key factor in aging. Scientists have successfully reversed aging in mice by targeting specific genes responsible for cellular deterioration. Future applications could involve customizing human DNA to resist age-related diseases like Alzheimer's and heart disease. However, ethical concerns and the potential for unintended consequences remain major hurdles in advancing this technology for human longevity. Early trials show about a 70% success rate in correcting genetic mutations, but long-term effects in humans remain under study. The next thing is senolytics, killing zombie cells. The concept of senescent cells was first identified in 1961 by Leonard Hayflick, who discovered that normal human cells have a limited number of divisions before they stop growing, a phenomenon now known as Hayflick limit. As we age, our bodies accumulate senescent cells, cells that stop dividing but don't die. These zombie cells cause inflammation and contribute to age-related diseases. Senolytic drugs are being developed to remove these cells, potentially increasing lifespan and health span. Research has shown that clearing senescent cells in mice extends their lifespan by up to 36%. Senolytics work by selectively targeting and eliminating these dysfunctional cells, reducing inflammation and promoting tissue repair. Some drugs, like dasatinib and quercetin, are already in clinical trials for their potential anti-aging effects. Despite promising results, challenges remain in ensuring the safety and efficacy of these treatments in humans. Current clinical trials show a 60 to 75% effectiveness in improving health markers related to aging. Another possibility is regenerative medicine and stem cells. Stem cells have the unique ability to repair damaged tissues and organs. Scientists are developing stem cell therapies to regenerate aging tissues, restore organ function, and even reverse some effects of aging. Induced pluripotent stem cells allow researchers to reprogram adult cells into a more youthful state. In trials, stem cell injections have improved heart function, repaired cartilage, and even reversed signs of neurodegenerative diseases. However, issues like immune rejection and uncontrolled cell growth pose significant risks. Ongoing research aims to refine stem cell therapies, making them safer and more effective for widespread use in anti-aging medicine. Current studies indicate an 80% success rate in treating age-related conditions, though long-term safety is still under evaluation. Up next, we have mind-blowing tech on artificial organs and bioprinting. 3D bioprinting technology is enabling the creation of lab-grown organs using a patient's own cells. This could eliminate organ donor shortages and allow people to replace aging or failing organs, extending life significantly. Scientists have successfully printed functional tissues, including skin, blood vessels, and even parts of the heart. Bioprinting could revolutionize transplant medicine by creating fully functional, patient-specific organs. However, challenges like vascularization, ensuring blood flow in printed organs, must be overcome. With continued advancements, we may one day see complete, transplantable organs produced on demand, reducing organ failure-related deaths and significantly extending human longevity. Current trials show a 50 to 65% success rate in small-scale tissue transplantation, with fully functional organ transplantation still in early experimental stages. That being said, 3D bioprinting is not as successful as the next technology we have. Nanotechnology in medicine. Tiny nanobots could one day repair cells, remove harmful substances, and target diseases at the molecular level. Companies like Nanobots medical researchers are developing microscopic robots that could circulate through the bloodstream to maintain and repair the body in real time. These nanobots could be programmed to clear arterial plaque, eliminate cancer cells, or even repair DNA damage. Researchers are also exploring self-replicating nanomachines that could provide continuous maintenance to the human body. While these concepts are still theoretical, early prototypes have demonstrated promising results in targeted drug delivery and disease treatment. The next step is refining these technologies for safe human use. Early-stage trials report a 55 to 70% success rate in experimental cancer treatments using nanobots. But I think the more successful way is calorie restriction. Mimetic studies on caloric restriction in animals show a link to increased lifespan. Scientists are developing drugs that mimic the benefits of fasting without the need to reduce food intake, potentially slowing aging and reducing age-related diseases. Resveratrol, a compound found in red wine, and rapamycin, an immunosuppressant drug, have both been shown to extend lifespan in animal studies. These compounds activate longevity-associated pathways like AMPK and mTOR inhibition. Clinical trials are underway to determine their effectiveness in humans. If successful, these drugs could provide the life-extending benefits of caloric restriction without the need for drastic dietary changes. Current human trials report 65 to 80% effectiveness in improving biomarkers linked to aging. However, keep in mind that some people are simply extremely wealthy. They prefer to look to the future rather than live in the present, so this is for them: cryonics. Freezing for the future. Cryonics involves freezing a person's body after death in hopes that future technology can revive and heal them. While no one has been revived yet, ongoing advancements in cryopreservation suggest this could one day be a viable path to extended life. Vitrification, a process that prevents ice crystal formation, has improved tissue preservation, making cryonics more feasible. Some scientists believe that advancements in molecular repair and artificial intelligence may eventually allow for revival. However, major challenges remain, including legal and ethical concerns, as well as the need to develop technology capable of reversing the biological damage caused by freezing. Current preservation success rates for individual organs are around 80%, but whole-body revival remains purely theoretical. On the other hand, some researchers believe that AI and brain-computer interfaces could allow us to upload our consciousness to digital platforms. Companies like Neuralink are working on brain-machine interfaces that might one day allow humans to transfer their minds into artificial bodies. Advanced AI could replicate human thought patterns, potentially preserving memories and personalities indefinitely. Scientists are also exploring whole-brain emulation, where neural connections are mapped and simulated in a digital format. While this concept remains highly theoretical, breakthroughs in neuroscience and computing power are bringing us closer to the possibility of achieving digital immortality. Current AI brain interface success rates in early tests are around 50 to 65%, with full consciousness transfer still unproven. That said, my personal favorite is epigenetic reprogramming. Epigenetic changes influence how genes are expressed over time. Scientists are researching ways to reset these changes, effectively turning back the biological clock and restoring youthful function in aging cells. In animal studies, epigenetic reprogramming has successfully reversed signs of aging and restored tissue function. Key molecules, such as Yamanaka factors, have been identified as potential tools for cellular rejuvenation. This technology could lead to groundbreaking anti-aging therapies, but researchers must ensure that reprogramming cells does not increase the risk of cancer or other unintended consequences. Future clinical trials will determine its feasibility in humans. Current success rates in experimental models range from 70 to 85% in reversing some age-related changes. Finally, last but not least, blood transfusions and parabiosis research suggests that young blood transfusions may have rejuvenating effects. Studies on mice have shown that blood from younger individuals can reverse aging markers in older animals. While human applications are still in their early stages, companies are exploring their potential. Some researchers believe that young plasma contains proteins and factors that can improve brain function, muscle strength, and overall health. Clinical trials, such as those conducted by Alkahest, are investigating whether plasma-based therapies can slow cognitive decline in Alzheimer's patients. Ethical concerns and the need for controlled studies remain key challenges in proving its long-term benefits. Current trials report a 50 to 70% success rate in improving cognitive function in older adults. Would you opt for any of these life-extending technologies if given the chance? Well, what I think is that while these technologies are still developing, they represent a future where aging could be slowed, reversed, or even eliminated. Whether through genetic modification, regenerative medicine, or digital consciousness, the dream of extending human life is closer than ever before. And that's that for today's video. Thanks for watching, and we will see you in the next one.